All right, guys, starting off here on number 1 and number 2. So number 1, I would always multiply the regular numbers first, and that's just like regular multiplication, so that's going to be a positive 18 there. Now the exponents I am going to add, so it's going to be x to the negative 6th, and then y to the positive 8. So you kind of add those separately with their x's and y's. And then the last thing I would do there is just drop that 6 power down to the bottom. Remember that the 18 really has a power of 1, so it is going to stay on top, so there you go. Number 2, this 3 is gonna send in there, but I need to put a 1 there for the 4. So that'll become negative 4 to the 3rd power, and then x to the negative 6th, and then y to the 21st. So then negative 4 to the 3rd power would be negative 4 times negative 4 times negative 4. Now I know that those first two multiply to make 16, not 18, 16. So then I multiply that by 4 again. And then, so I get 64, but it is negative 64 because I had one more negative back there. So it's going to be negative 64 here. And then I'm going to drop that x to the 6th to the bottom and then put the y to the 21st on top. Now, I am not going to move the negative 64 to the bottom because it really doesn't have a negative exponent. Its exponent is still positive 1. And so I don't move negative numbers to the bottom, just negative exponents. All right, next up, number 3. On this one, the kind of key is to reduce these two first. So that's actually going to be 2 over 1, and I'm not even going to put the 1 there. So anytime you see you can reduce something like that, it can avoid some big numbers, so we definitely want to do that. So then I want to send in the 3rd power into there. Remember that we do have a 1 right there, so I'm going to let you guys try that one on your own. Number 4 here, I am going to send in the 3rd power there. So it's going to become 3 to the negative 3rd, x to the negative 9th, and z to the negative 9th. Now, we have a bunch of negative exponents there, so those all have to flip. And then I'll do 3 to the 3rd is just 3 times 3 times 3, so that's really 9 times 3. And so that's 27, x to the 9th, and z to the 9th on top. All right, number 6, we just have to move the negative exponents. So 12 has an exponent of 1, so that's not moving. The b does not have a negative exponent either, so that's not going to move, but I'm going to move this c up, and I'm going to move the a down, and that's it. All right, these ones I want to break down the radical here, so it'll be 9 and 3, and then 3 and 3. And then the variables, I just kind of list them out, however many I have. And now we're going to look for twins, so I have twin 3's right there, I have twin x's there, twin y's, and twin y's. I only have one loner in this set 3, so he's going back in the house, and then I would just call that y squared. And there you go. All right, number 9 and number 10 is the 3rd root. And so since it's the 3rd root, we're going to look for triplets instead of twins. So I'm still going to break it down the same way. So this will be 2 and 3, and then that's 2 and 4, which is 2 and 2. But like I said, we're looking for triplets here. So I'm going to group those 3 together, which means that these guys are loners. Now, when we group these together, they go out of the house as 1. And then the 2 and the 3 go back in the house because they are loners. The house, though, stays as a 3rd root, so that's why I kept that 3 in there, right there. And then I would just finish this off by calling it 2 times the cube root, the 3rd root of 6. All right, number 12, I'm just going to combine like terms here. So I actually see that these two would cancel each other out. And so I'm just left with negative 3 rad 5. The other way you can think of it is negative 2 plus 2 is 0. And then I have the negative 3 rad 5. Whenever we add these together, the inside does not change. We just add the numbers out front. Number 14. So right now I could combine these two and make that 1 radical 2 because we combine the numbers out front, but then just keep the inside the same. 54 I need to break down as a 9 and 6, which is 3, 3, and then 2, 3. So then it looks like I want to take these 3's outside. So that'll be 3 radical, and then these loners will go back inside. Oh, but I already had this 3 out here, so I'm going to multiply those 2. So those where those 2 3's are coming from. So I have negative 9 rad 6, and then I'm just going to bring this down 1 rad 2. Those are different radicals, so we cannot combine them, so that's just our answer. All right, next up, number 16. So on these ones, whenever they're multiplying together, I kind of just start breaking them down. And then I know that I can just combine kind of the children from both of these. So I'm just going to put them all together. And then I'm just going to list out 5 n's here. It's 3 for this one and then 2 for that one. And so I can just kind of find twins on each of these. Since they're multiplying, they're kind of all together anyway. So what it looks like I have here outside is 2n and n again. And then on the inside I have a loner 5, 3, and n. So that's 5 times 3 times n. And so unlike addition, I can do this all together. Addition, I kind of have to keep them separate. And so then that's my final answer. So same idea here for number 18. So this one just breaks down as a 3. That's a 3 and a 4, which is a 2 and a 2. And then for my variables, looks like I have 4 x's all together, and then 6 y's. So once again, I'm just putting them all together here. So now we'll group them up. So it looks like we don't have anybody left in the house. I just have 3 times 2 times x times x times x times y times y. So I would call that 6x to the third y squared. All right, next up, number 20. So on this one, we want to rationalize the denominator by multiplying by the radical down there. So that's just going to be rad 10 over rad 25, which is just a regular 5 on bottom and a rad 10 up top. Now 22 is the same idea, but what I want to do on 22 first of all, I want to split them up. And then I want to reduce this first. So I'm going to divide the top and the bottom by 4. So I'm really going to do rad 6 over rad 5. So we can always do this if we can reduce the fraction. I couldn't do that with 2 and 5, but with 24 and 20 I can. And so now I'll multiply by rad 5 over rad 5. And so that gives me rad 30 over rad 25, which would just be rad 30 over 5. All right, next one here, we want to write this in exponential form. So whenever you're writing this, the numerator is the exponent, and then the denominator is the root. So that's it. 26 is kind of the same, but in the other direction. So I'm going to do the 7th root of x. That goes in the little house there. And then the 9th power goes on the outside. All right, next up here, these exponential equations, I need to make them have the same base. So looking at 28, I cannot do these both. I can't write 8 with a 4 to some power. And so I'm going to do these both as 2's. So I know that 2 to the 3rd power gives me 8. And then I know if I do 2 to the 3rd power is 8. If I do 2 to the 4th power, that's just times 2. So that is going to be 16. So this one's going to be 2 to the 4th power. Now that I have them, or actually I'm going to distribute this in there. So I get 2 to the 3x plus 6. And now that I have the same base, I can drop the bases. So really, I just get 3x plus 6 equals 4, minus 6, so 3x equals negative 2, and x equals negative 2/3. All right, next up here, we're going to write the equation for the graph. I see it's kind of hard to see the y-intercept there. So what I would do here is I would first kind of examine growth or decay, and I'd say this one is growth because it is increasing. And so then I know that my base must be greater than 1. Now, I see that this one has a base that's 1/2, so I know B is incorrect. This one has a base that's 1/3, so that's incorrect as well. So now I need to only decide between A or D. So what I'm going to do for that one is find a point. I see a good point right there as 1, 1. And so what I'm going to do here is I'm going to test these answers out by just plugging in my x and y and seeing if it comes out correct or not. So I'll try out option A first. I'm just going to plug in 1 for y, and then also 1 for x, just because that's my point right there. And so I know 4 to the 1st power is just 4. I'm going to call it 4 over 1 though. And then we can reduce this. And so what's left over here is 1 equals 2. Now obviously that's not true, so A is incorrect. So by the process of elimination, I know it's D, but if you wanted to test this point out, it would say plug in once again 1 for y, and then again 1 for x. And then I know that 3 to the 1st power is just 3 over 1. So then these cancel, and I get 1 equals 1. So that does check out. So always grab a point from the graph if you can and plug it into the multiple choices and see what works. All right, next up we want to do some substitution here. So I see I have an isolated variable, so I'm going to swap it out for that y in the other equation. All right, so now I'm going to distribute that 4 in there. So I get negative 3x plus 8x plus 12 equals 2. All right, so now I'm going to combine these guys. So I get 5x plus 12 equals 2. I get 5x equals negative 10 if I subtract 12 from each side to try to isolate x. And we'll divide both sides by 5, so x equals negative 2. Now I need to find y, though, so I'm going to plug it back into this equation. So y equals 2 times negative 2 plus 3. And so y equals negative 1. So I get negative 2 comma negative 1. All right, this one I want to solve with elimination. So I need to multiply by something that's going to eliminate. I'll try to eliminate the x's here. I see I can just multiply this by negative 5. And that's going to turn that into a positive 5x minus 40y equals 21 times 5 is negative 105. And then this top equation, I'm just going to keep that the same. And what I notice here is, and why I chose that negative 5 is so now my x's cancel out. I get negative 47y equals, and I need to do 105 minus 11 there. So that's negative 94. I'm going to divide that by negative 47. So then y equals, and I think that's going to come out to 2. Let me just make sure 2 times 47 is 94. And it is, so that's just going to be a positive 2 there. Now I need to find x, so I'm going to plug that back in. I'm going to go ahead and plug it into this equation. So negative x plus 8 times 2 equals 21. So that's negative x plus 16 equals 21. We'll subtract the 16 here. Negative x equals 5, and then I'll divide by negative 1. So x equals negative 5. So I would list my answer as negative 5 comma 2. All right, next up, number 36. So on this one, I want to solve it by graphing. So I need to graph both of these, but I want to get them into y equals mx plus b to graph them. So I'll start off with the first one here, 5x minus 3y equals negative 9. I want to isolate y, so I'm going to subtract the 5x over. And then I'm going to divide everything by negative 3. So y equals 5 over 3x plus 3. So I'll graph that. There's my y-intercept. I can't go up 5 over 3, so I'm going to go down 5 and backwards 3 right there. I see that this still gives me a positive slope, which I need there because we do have a positive m right there. All right, so now I'm going to do the other one. So x minus 3y equals 3. Subtract the x over. Negative 3y equals negative x plus 3. And then we'll divide by negative 3. So y equals 1/3 x minus 1, since that's really a 1 right there. All right, so we'll start with our y-intercept here at negative 1, up 1 over 3, and then back 1 over 3. So I see my intersection is right there at the point negative 3 comma negative 2, so that's my answer. All right, lastly here, we just need to state on these two whether it's growth or decay. So I know that, and this is the one I'm really looking at, and so I know that when I have that base is less than 1, that is always going to be decay. And then it's asking me also, what is this plus 4 out back? So remember, when it's out back, then it's a up or down shift. This one will be an up 4 shift. Remember that the y kind of tells the truth, and so if it's positive, it's up, negative is down. But remember that x lies, so that if it's positive, it's left, and if it's negative, it's right.